In this video, we will discuss buoyancy and how it's connected to Archimedes' principle. In short, a buoyant force acts on any object that is submerged underwater. The magnitude of this force is proportional to the object's volume, and the direction of the buoyant force is opposite that of the gravitational force, so usually upwards. Since the force due to buoyancy acts in the opposite direction as the gravitational force, things appear to be lighter underwater. But why does such a buoyant force occur? Consider this situation of an object submerged in some fluid. Since pressure increases with depth, the pressure below the object is higher than the pressure above it. As pressure is directly proportional to force, this also means that the force below is stronger than the force above, such that a resulting upwards force remains. This is exactly the buoyant force. Now let's investigate this a bit more mathematically. The buoyant force is defined as the difference of the force below minus the force above. Force is pressure times area, so we have P2A minus P1A. Next, we use the hydrostatic equation to write pressure as the fluid density times G times the depth where we measure the pressure. By writing common factors to the front, we can recognize the object's volume as H2 minus H1 times the area A. Here, the density is a property of the fluid, the volume is a property of the object, and G is a constant. Furthermore, density times volume is mass. In particular, this mF denotes the mass of the fluid that would be in the volume V, but is actually displaced by the object. This looks like a gravitational force. Here we already found Archimedes' principle. The buoyant force acting on an object is equal to the weight of the displaced medium. This is not only true for fluids, but for any medium. For instance, Archimedes' principle is the reason why a balloon filled with helium can float. Helium is simply lighter than the same volume of air. Finally, let us investigate how we can determine whether an object floats or sinks in a given medium. We will see that this is decided by the respective densities. Consider the same situation as before, where some object with density ρO is submerged in a fluid with density ρF. There are two forces acting here, the gravitational force and the buoyant force. Due to Newton's second law of motion, the acceleration of the object is given by the sum of all forces, so Fb minus Fg. We can write this using the densities as ρF minus ρO times the volume and G. Now, if ρO is larger than ρF, the acceleration is negative, therefore the object sinks down. On the other hand, if ρO is smaller than ρF, the acceleration is positive and the object floats up. And that's pretty much it for this video. Thanks for watching.